Welcome to Advanced Con Ed's 6-hour Oklahoma 2015 Plumbing and Fuel Gas Code Update, Part 2. Advanced Con Ed presents the significant changes to the 2015 International Plumbing Code with the State of Oklahoma Uniform Building Code Commission's amendments and modifications, Part 2. Introduction. Welcome, and thank you for selecting Advanced Con Ed to provide the continuing education you need to fulfill your licensing requirements. At Advanced Con Ed, we strive to present you with the most up-to-date codes and relevant safety information to keep you both technically current and safe on the job. This presentation provides you with the significant changes to, followed by a discussion of the ICC's 2015 International Plumbing Code, presented in black text, as well as the Oklahoma Uniform Building Code Commission's amendments and modifications, presented in blue text. And now, Advanced Con Ed is proud to present the significant changes to the 2015 International Plumbing Code with the State of Oklahoma Uniform Building Code Commission's amendments and modifications, Part 2. Section 607.2, Hot or Tempered Water Supply to Fixtures. 607.2, Hot or Tempered Water Supply to Fixtures. The developed length of hot or tempered water piping from the source of the hot water to the fixtures that require the hot or tempered water shall not exceed 50 feet. Recirculating system piping and heat traced piping shall be considered to be sources of hot or tempered water. Discussion. Fixtures that require hot or tempered water must be located within the specified distance of the hot water source. The previous allowance of 100 feet has been reduced to 50 feet in order to minimize the time it takes to get hot water to a fixture. A large amount of water and energy is wasted unnecessarily while running the water and waiting for the heated water to get to the outlet. Hot water supply is an area where the proper design of the system is critical to create sizable energy and water savings. Section 607.2.1, Hot Water Temperature Maintenance System Controls. 607.2.1, Hot Water Temperature Maintenance System Controls. For hot water distribution system circulating pumps and heat trace, the pumps and heat trace shall be arranged to be turned off automatically when there is not hot water demand. Ready access shall be provided to the operating controls. This section and section 607.2.1.1 shall not apply to hot water temperature maintenance system controls in group R2, R3, and R4 occupancies that are 3 stories or less in height above grade plane. Hot water temperature maintenance system controls in group R2, R3, and R4 occupancies that are 3 stories or less in height above grade plane shall be in accordance with section R 403.4.1 of the International Energy Conservation Code. 607.2.1.1, Storage Tank Hot Water Circulation Systems. Circulating pumps intended to maintain storage tank water temperatures shall have controls that will limit operation of the pump from heating cycle startup to not greater than 5 minutes after the end of the cycle. Ready access shall be provided to the operating controls. Section 607.3 Hot Water Thermal Expansion Pressure Control. 607.3 Thermal Expansion Control. Where a storage water heater is supplied with cold water that passes through a check valve, pressure reducing valve, or backflow preventer, a thermal expansion tank shall be connected to the water heater cold water supply pipe at a point that is downstream of all check valves, pressure reducing valves, and backflow preventers. Thermal expansion tanks shall be sized in accordance with the tank manufacturer's instructions and shall be sized such that the pressure in the water distribution system shall not exceed that required by Section 604. Section 607.3 Hot Water Thermal Expansion Pressure Control. 607.3 Thermal Expansion Control. Where a storage water heater is supplied with cold water that passes through a check valve, pressure reducing valve, or backflow preventer, a thermal expansion tank shall be connected to the water heater cold water supply pipe at a point that is downstream of all check valves, pressure reducing valves, and backflow preventers. Thermal expansion tanks shall be sized in accordance with the tank manufacturer's instructions and shall be sized such that the pressure in the water distribution system shall not exceed that required by Section 604. Section 607.3 Hot Water Thermal Expansion Pressure Control continued. Discussion. A thermal expansion tank is now the only code-approved method for controlling thermal expansion cause pressure increases created by water being heated in a closed system. In any arrangement where there is a pressure reducing valve, a check valve, or a backflow preventer in the cold water piping that leads to a storage type water heating system, a means for compensating for system pressure increases caused by thermal expansion must be installed. Previously, other methods for relieving thermal expansion caused pressure increases could be pressure relief valves, but not the temperature and pressure relief valve on the hot water storage tank. The relief valve method is no longer code approved. Proper sizing of the required thermal expansion tank is required so the water system pressure is limited to not greater than 80 psi. The pressure limitation indicated in Section 604.8 when thermal expansion caused pressure increases occur. The code does not prescribe methods for sizing thermal expansion tanks. Section 607.5 Hot Water Piping Insulation. 607.5 Pipe Insulation. Hot water piping in automatic temperature maintenance systems shall be insulated with 1 inch of insulation having a conductivity not exceeding 0.27 BTU per inch per hour per square foot per degree Fahrenheit. The first 8 feet of hot water piping from a hot water source that does not have heat traps shall be insulated with 0.5 inches of material having a conductivity not exceeding 0.27 BTU per inch per hour per square foot per degree Fahrenheit. Discussion. The minimum insulation requirements for hot water piping and automatic temperature maintenance systems have historically been located in the IECC. Insertion of this important information into the IPC will be a benefit to the user in determining what type and thickness of insulation is required on a hot water piping system. The new text that has been added is a word-for-word extraction from the IECC. Sections 608.8, 608.8.1, and 608.8.2. Identification of non-potable water. 608.8. Identification of non-potable water. Where non-potable water systems are installed, the piping conveying the non-potable water shall be identified either by color marking or metal tags in accordance with sections 608.8.1 through 608.8.3. All non-potable water outlets, such as hose connections, open-ended pipes, and faucets, shall be identified at the point of use for each outlet in accordance with sections 608.8.1 through 608.8.3. Sections 608.8, 608.8.1, and 608.8.2. Identification of non-potable water continued. 608.8.1 Signage required. All non-potable water outlets, such as hose connections, open-ended pipes, and faucets, shall be identified with signage that reads as follows. Non-potable water is utilized for application name. Caution: non-potable water. Do not drink. The words shall be legibly and indelibly printed on a tag or sign constructed of corrosion-resistant, waterproof material, or shall be indelibly printed on the fixture. The letters of the words shall not be less than 0.5 inches in height and in colors in contrast to the background on which they are applied. In addition to the required wordage, the pictograph shown in Figure 608.8.1 shall appear on the signage required by this section. Sections 608, 608.8.1, and 608.8.2. Identification of non-potable water continued. 608.8.2. Distribution pipe labeling and marking. Non-potable distribution piping shall be of the color purple and shall be embossed or integrally stamped or marked with the words "Caution, non-potable water, do not drink," or shall be installed with a purple identification tape or wrap. Pipe identification shall include the contents of the piping system and an arrow indicating the direction of flow. Hazardous piping systems shall also contain information addressing the nature of the hazard. Pipe identification shall be repeated at intervals not exceeding 25 feet and at each point where the piping passes through a wall, floor, or roof. Lettering shall be readily observable within the room or space where the piping is located. Sections 608, 608.8.1, and 608.8.2. Identification of non-potable water continued. Discussion. Water conservation practices are creating the need to use an increasing number of alternate sources of water instead of potable water for a variety of purposes. Previous editions of the IPC limited the identification of non-potable water systems to only those systems installed in buildings and only required reclaimed, rain, and gray water piping to be identified with the color purple, creating confusion as to whether or not outlets not within buildings need to be identified. This created a need for identification of water piping carrying the alternate water so that inappropriate connections to such piping systems are not made. The code has been changed to include all types of non-potable water for the required marking. All systems and outlets for non-potable water should now be identified regardless of location. The identification words for non-potable water piping have been changed to be in alignment with current industry practices for labeling piping and identification tapes. For fixtures using non-potable water, a pictograph symbol that conveys the meaning of the words is required to be on the signage. Section 702.5 Temperature Rating of Drainage Piping. 702.5 Temperature Rating. Where the wastewater temperature will be greater than 140 degrees Fahrenheit, the sanitary drainage piping material shall be rated for the highest temperature of the wastewater. Discussion. The drainage piping materials indicated in tables 702.1 through 702.4 are all capable of continuously conveying 140 degree Fahrenheit wastewater. Section 803.1 required that higher temperature wastewater be cooled before it was allowed to enter the drainage system. However, some piping materials are capable of the higher temperature flows. Therefore, if piping with a higher temperature rating is used, there is no need for cooling wastewater before it is discharged to the system. Section 803.1 has been deleted to allow Section 702.5 to be added to the code. Section 703.6 Connection to Combined Sanitary and Storm Public Sewer. 703.6 Combined Sanitary and Storm Public Sewer. Where the public sewer is a combined system for both sanitary and storm water, the sanitary sewer shall be connected independently to the public sewer. Discussion. Even though a public sewer system is a combined sanitary and storm sewer, the connections to such a public sewer from a building must be made independently. Some older cities having combined sanitary and storm sewers are working on installing separate storm sewer systems to reduce or eventually eliminate stormwater discharge to the public sanitary sewer system. Buildings that already have separate sewer lines will be easier to convert to the separated public sewer systems. Sections 704.3, 711.2.1 Horizontal Branch Connections. 704.3 Connections to Offsets and Bases of Stacks. Horizontal branches shall connect to the bases of stacks at a point located not less than 10 times the diameter of the drainage stack downstream from the stack. Horizontal branches shall connect to horizontal stack offsets at a point located not less than 10 times the diameter of the drainage stack downstream from the upper stack. 711.2.1 Omission of vents for horizontal stack offsets. Vents for horizontal stack offsets required by Section 711.3 shall not be required where the stack and its offset are one pipe size larger than required for a building drain. See Table 710.11, and the entire stack and offset are not less in cross-sectional area than that required for a straight stack plus the area of an offset vent as provided for in Section 907. Sections 704.3, 711.2.1 Horizontal Branch Connections. Discussion. As a result of the deletion of Section 711.2, horizontal branches can now be connected at any point in a stack above or below a horizontal offset. Research has shown that the turbulent flow in the horizontal offset occurs within the first 10 pipe or stack diameters downstream of the stack. This is the same condition that occurs in a building drain downstream the base of a stack. At this point, the flow in the horizontal pipe becomes non-turbulent, open channel flow. Any connection downstream of where turbulent action is known to occur is now permitted because the concerns for avoiding connections in a turbulent zone are identical. The allowance for horizontal connections to a horizontal offset now mirrors the requirements for connections at the base of the stack. Section 705.11.2 Solvent Cementing. 705.11.2 Solvent Cementing. Joint surfaces shall be clean and free from moisture. A purple primer that conforms to ASTM F656 shall be applied. Solvent cement not purple in color and conforming to ASTM D2564, CSA B137.3, CSA B181.2, or CSA B182.1 shall be applied to all joint surfaces. The joint shall be made while the cement is wet and shall be in accordance with ASTM D2855. Solvent cement joints shall be permitted above or below ground. Section 708.1.3 Building Drain and Building Sewer Junction. 708.1.3 Building Drain and Building Sewer Junction. The junction of the building drain and building sewer shall be served by a cleanout that is located at the junction or within 12 feet of the developed length of piping upstream of the junction. For the requirements of this section, the removal of the water closet shall not be required to provide cleanout access. Section 708.1.6 Cleanout Plugs. 708.1.6 Cleanout Plugs. Cleanout plugs shall be brass, plastic, or other approved materials. Cleanout plugs for borosilicate glass piping systems shall be of borosilicate glass. Brass cleanout plugs shall conform to ASTM A74 and shall be limited for use only on metallic piping systems. Plastic cleanout plugs shall conform to the reference standards for plastic pipe fittings as indicated in Table 702.4. Cleanout plugs shall have a raised square head, a countersunk square head, or a countersunk slot head. Where a cleanout plug will have a trim cover screw installed into the plug shall be manufactured with a blind end threaded hole for such purpose. Section 708.1.10 Cleanout Access. 708.1.10 Cleanout Access. Required cleanouts shall not be installed in concealed locations. For the purposes of this section, concealed locations include, but are not limited to, the inside of plenums, within walls, within floors or ceilings, assemblies, below grade, and in crawl spaces where the height from the crawl space floor to the nearest obstruction along the path from the crawl space opening to the cleanout location is less than 24 inches. Cleanouts with openings at finished walls shall have the face of the opening located within 1 1/2 inches of the finished wall surface. Cleanouts located below grade shall be extended to grade level so that the top of the cleanout plug is at or above grade. A cleanout installed in a floor or walkway that will not have a trim cover installed shall have a countersunk plug installed so that the top surface of the plug is flush with the finished surface of the floor or walkway. Section 708.1.10.1 Cleanout plug trim covers. 708.1.10.1 Cleanout plug trim covers. Trim covers and access doors for cleanout plugs shall be designed for such purposes and shall be approved. Trim cover fasteners that thread into cleanout plugs shall be corrosion resistant. Cleanout plugs shall not be covered with mortar, plaster, or any other permanent material. Section 708.1.10.2 Floor Cleanout Assemblies. 708.1.10.2 Floor Cleanout Assemblies. Where it is necessary to protect a cleanout plug from the loads of vehicular traffic, cleanout assemblies in accordance with ASME A 112.36.2M shall be installed. Section 708 Cleanouts for Drainage and Waste Systems. Discussion. Section 708 has been reorganized in a format that better clarifies the requirements for cleanouts. Section 106.2, Item 2, allows the removal and reinstallation of water closets without the need for a permit. The rewrite of Section 708 does not change this allowance except for one location, where the removal of a water closet is necessary for rotting the building drain to building sewer junction. Where cleanout plugs must accept trim cover screws, the cleanout plug is now required to have a blind end threaded hole to accept the trim cover screw, and that the trim cover screws be corrosion resistant. Test tees are frequently installed for both pressure testing of a piping system during rough-in and as a cleanout. When a test tee is installed as a cleanout and accessed through an opening in a wall, the face of the cleanout opening must be within 1 1/2 inches of the face of the wall so that personnel performing drain cleaning can easily access the opening and perform rotting without damage to the adjacent wall. Section 708, Cleanouts for Drainage and Waste Systems, continued. Discussion, continued. Cleanouts and floors do not necessarily require specialized cleanout cover assemblies as long as a countersunk cleanout plug is installed flush with the floor. However, where vehicular traffic is anticipated, cleanout assemblies in accordance with ASME A 112.36.2M must be used. The requirement to provide a cleanout at the base of each waste or soil stack has been removed. There only needs to be one cleanout access at the most upstream end of the horizontal drain pipe and every 100 feet from that point. The intent of the previous requirement was to make sure there was an access point for routing every length of horizontal piping connected to the base of a stack. Section 712.3.3 Sump pump and ejector discharge pipe and fittings. 712.3.3 Discharge pipe and fittings. Discharge pipe and fittings serving sump pumps and ejectors shall be constructed of materials in accordance with sections 712.3.3.1 and section 712.3.3.2 and shall be approved. 712.3.3.1 Materials. Pipe and fitting materials shall be constructed of brass, copper, CPVC, ductile iron, PE, or PVC. 712.3.3.2 Ratings. Pipe and fittings shall be rated for the maximum system operating pressure and temperature. Pipe fitting materials shall be compatible with the pipe material. Where pipe and fittings are buried in the earth, they shall be suitable for burial. Section 712.3.3 Sump pump and ejector discharge pipe and fittings. Continued. Discussion. A simple listing of materials allowed for use in force main applications for discharge pipe and fittings has added clarity where there was little guidance. It is now also stated that piping and fittings shall be rated for the maximum system operating pressure and temperature, and where buried in the earth, they shall be suitable for that purpose. Section 712.3.5 Sump pump connections to the drainage system. 712.3.5 Pump connection to the drainage system. Pumps connected to the drainage system shall connect to a building sewer, building drain, soil stack, waste stack, or horizontal branch drain. Where the discharge line connects into a horizontal drainage piping, the connection shall be made through a Y fitting into the top of the drainage piping, and such Y fitting shall be located not less than 10 pipe diameters from the base of any soil stack, waste stack, or fixture drain. Section 712.3.5 Sump pump connection to the drainage system. Continued. Discussion. Building sewers and building drains, soil stacks, waste stacks, and horizontal branch drains are now acceptable points of termination for sump pump discharge lines. When the discharge line connects to a soil stack or waste stack, Section 706.3 would apply, requiring drainage fittings to be installed to guide sewage and waste in the direction of flow. Fittings acceptable for changes of direction are already addressed in Table 706.3. For a connection to a horizontal drain pipe, the connection shall continue to be made through a Y-type fitting into the top of the drainage piping, and such Y-type fitting shall be located not less than 10 pipe diameters from the base of any soil stack, waste stack, or fixture drain, a change from the previous minimum distance of 10 pipe diameters. Section 715.1 Fixture protection from sewage backflow. 715.1 Sewage backflow. Where plumbing fixtures are installed on a floor with a finished floor elevation below the elevation of a manhole cover of the next upstream manhole in the public sewer, such fixtures shall be protected by a backwater valve installed in the building drain or horizontal branch serving such fixtures. Plumbing fixtures installed on a floor with a finished floor elevation above the elevation of the manhole cover, the next upstream manhole in the public sewer, shall not discharge through a backwater valve. Exception. In existing buildings, fixtures above the elevation of the manhole cover of the next upstream manhole in the public sewer shall not be prohibited from discharging through a backwater valve. Section 715.1 Fixture Protection from Sewage Backflow continued. Discussion. Existing buildings built before the code required backwater valves for fixtures on floor levels below the elevation of the next upstream manhole cover are at risk for sewage backflows caused by public sewer problems. Installation of a backwater valve after a building is built presents a problem of how to separate the drainage flow from fixtures on floors below the next upstream manhole cover from fixtures on floors above the next upstream manhole cover. The drainage piping within the building is so integral to the construction of the building that separation of the drainage flows for installation of a backwater valve in accordance with the code is often impossible. A new exception specifically addresses the common problem encountered with installation of a backwater valve for an existing building. This exception allows for existing buildings only. Installation of a backwater valve for all fixtures in a building, even if those fixtures are on a floor above the next upstream manhole cover elevation. A building owner should have the ability to protect his or her property from public sewer surcharging that could cause an overflow within the building. Section 716 Vacuum Drainage Systems. 716.1 Scope. Vacuum drainage systems shall be in accordance with Section 716.2 through 716.4. 716.2 System Design. Vacuum drainage systems shall be designed in accordance with the vacuum drainage system manufacturer's instructions. The system layout, including piping layout, tank assemblies, vacuum pump assembly, and other components necessary for proper function of the system, shall be in accordance with the manufacturer's instructions. Plans, specifications, and other data for such systems shall be submitted to the code official for review and approval prior to installation. Only the significant sections of this new section are shown. Section 716 Vacuum Drainage Systems continued. Discussion. Vacuum drainage systems have been commonly used to transport wastewater flows in ships and in prisons. These systems are less prone to clogging than gravity drainage systems and are not required to have conventional trap venting systems or carefully sloped drainage piping. In recent years, vacuum drainage systems have been receiving greater attention as an alternative to gravity draining systems for all types of buildings because of the low water flows from fixtures caused by water conservation practices are causing solid waste transport problems in gravity type drainage systems. Vacuum drainage systems technology and design is well proven over many years of use in a variety of applications. Section 717 Replacement of Sewers by Pipe Bursting Method. 717.1 General. This section shall govern the replacement of existing building sewer piping by pipe bursting methods. 717.2 Applicability. The replacement of building sewer piping by pipe bursting methods shall be limited to gravity drainage piping of sizes 6 inches and smaller. The replacement piping shall be of the same nominal size as the existing piping. 717.4 Pipe. The replacement piping shall be manufactured with an SDR of 17 in compliance with ASTM F714. Section 717. Replacement of sewers by pipe bursting method. Continued. Discussion. Although the pipe bursting method of underground pipe replacement is used for large pipe diameter, the code limits its use to the replacement of pipes that are 6 inches or smaller. The only material that the code allows for sewer replacement is polyethylene plastic pipe, ASTM F714, having an SDR of 17 wall thickness. This pipe is an outer diameter and wall thickness controlled product. SDR 17 provides for an inside diameter that is very close to the inside diameter of PVC and cast iron sewer piping of the same size. An internal video camera survey of the completed installation is required to be reviewed by the code official prior to pressure testing of the replacement pipe, including all connections to the replacement pipe. Chapter 8. Indirect and Special Waste. Chapter 8. Indirect and Special Waste revoked. Sections 901.3 and 918.8. Air admittance valves for chemical waste vent systems. 901.3. Chemical waste vent systems. The vent system for a chemical waste system shall be independent of the sanitary vent system and shall terminate separately through the roof to the outdoors or to an air admittance valve that complies with ASSE 1049. Air admittance valves for chemical waste systems shall be constructed of materials approved in accordance with Section 702.5 and shall be tested for chemical resistance in accordance with ASTM F1412. 918.8 Prohibited installations. Air admittance valves shall not be installed in non-neutralized special waste systems as described in Chapter 8, except where such valves are in compliance with ASSE 1049, are constructed of materials approved in accordance with Section 702.5, and are tested for chemical resistance in accordance with ASTM F1412. Air admittance valves shall not be located in spaces utilized as supply or return air plenums. Sections 901.3 and 918.8 Air admittance valves for chemical waste vent systems continued. Discussion. The American Society of Sanitary Engineers, ASSE, has recently developed ANSI and ASSE Standard 1049 performance requirements for individual and branch type air admittance valves for chemical waste systems. Air admittance valves that are in compliance with the ANSI ASSE 1049 standard meet the materials requirements of Section 702.5 and are tested to ASTM F1412 for chemical resistance, are now allowed to serve as the vent for non-neutralized special waste systems as an alternative to chemical waste vent piping terminating outdoors. It is quite common to see laboratory sinks that receive chemical waste located in islands in the middle of rooms. To vent the traps of these sinks using vent piping that can only terminate outdoors requires extensive labor and materials, Allowing the use of AVVs will significantly reduce the cost of plumbing to these laboratories and similar facilities. Section 903.1 Roof Extension. 903.1 Roof Extension. Open vent pipes that extend through a roof shall be terminated not less than 10 inches above the roof. Where a roof is to be used for assembly or as a promenade, observation deck, sunbathing deck, or similar purposes, open vent pipes shall terminate not less than 7 feet above the finished occupiable surface within 10 feet horizontal distance. Discussion. The intent of this section is to require vent extensions to 7 feet only where the roof was to be used for assembly of people, such as may occur if there was an outdoor promenade, observation deck, sunbathing deck, or similar purposes. This requirement is not necessary for occasions when workers are temporarily repairing or replacing rooftop-mounted equipment, or where roofs might be used for people escaping a building when they have no other option for egress. Section 903.2 Frost Closure. 903.2 Frost Closure. Where the 97.5% value for outside design temperature is 0 degrees Fahrenheit or less, every vent extension through a roof or wall shall not be less than 3 inches in diameter. Any increase in the size of the vent shall be made not less than 1 foot inside the building's thermal envelope. Discussion. Section 903.2 has long required not less than 3-inch diameter vent terminals where the outside design temperature is 0 degrees Fahrenheit or less. The new requirement is for the vent pipes to increase diameter starting at not less than 1 foot inside the building's thermal envelope. Section 903.5 Location of vent terminals. 903.5 Location of vent terminal. An open vent terminal from a drainage system shall not be located directly beneath any door, openable window, or other air intake opening of the building or of an adjacent building, and any such vent terminal shall not be within 10 feet horizontally of such an opening unless it is at least 3 feet above the top of such opening. Discussion. Previous provisions required that a vent terminal located within 10 feet horizontally of a door, openable window, or other air intake opening be at least 2 feet above the top of the opening. However, the vertical separation requirement of 2 feet was inconsistent with similar sections in the other international codes. The 3-foot dimension has been around for many years and has been shown to be very effective in preventing sources of contamination from making their way into building openings. Section 915.2 Combination Waste and Vent System Sizing. 915.2 Connection. The combination waste and vent system shall be provided with a dry vent connected at any point within the system, or the system shall connect to a horizontal drain that is vented in accordance with one of the venting methods specified in this chapter. Combination waste and vent systems connecting to building drains receiving only the discharge from a stack or stacks shall be provided with a dry vent. The vent connection to the combination drain waste and vent pipe shall extend vertically of 6 inches above the flood level rim of the highest fixture being vented before offsetting horizontally. The horizontal length of a combination waste and vent system shall be unlimited. Section 915.2 Combination waste and vent system sizing continued. Discussion. These revisions clarify the intent of the code by adding that a combination waste and vent system size per the code is unlimited in horizontal length. There is no technical reason to continue to restrict the horizontal length of these piping systems that are commonly used where floor drains are installed in large, open areas that cannot accommodate vertical vent risers from the floor drains. These systems are practical to use in large commercial kitchens, markets, warehouses, and where island sinks are installed in laboratories and classrooms. Section 917 Single Stack Vent Systems. Single Stack Vent Systems 917.1 Where permitted, a drainage stack shall serve as a single stack vent system where sized and installed in accordance with sections 917.2 through 917.9. The drainage stack and branch piping shall be the vents for the drainage system. The drainage stack shall have a stack vent. 917.2 Stack size. Drainage stacks shall be sized in accordance with Table 917.2. Stacks shall be uniformly sized based on the total connected drainage fixture unit load. The stack vent shall be the same size as the drainage stack. A 3-inch stack shall serve not more than 2 water closets. Section 917 Single Stack Vent Systems continued. 917.3 Branch size. Horizontal branches connecting to a single stack vent system shall be sized in accordance with Table 710.1.2. Not more than 1 water closet shall discharge into a 3-inch horizontal branch at a point within a developed length of 18 inches measured horizontally from the stack. Where a water closet is within 18 inches measured horizontally from the stack, and not more than 1 fixture with a drain size of not more than 1.5 inches connects to a 3-inch horizontal branch, the branch drain connection to the stack shall be made with a sanitary tee. 917.4 Length of horizontal branches. The length of the horizontal branches shall conform to the requirements of section 917.4.1 through 917.4.3. Section 917 Single Stack Vent Systems continued. 917.4.1 Water Closet Connection. Water closet connections shall be not greater than 4 feet in developed length, measured horizontally from the stack. Exception. Where the connection is made with a sanitary tee, the maximum developed length shall be 8 feet. 917.4.2 Fixture Connections. Fixtures other than water closets shall be located not greater than 12 feet in developed length measured horizontally from the stack. 917.4.3 Vertical Piping in Branch. The length of vertical piping in a fixture drain connecting to a horizontal branch shall not be considered in the computing of the fixture's distance in developed length measured horizontally from the stack. Section 917. Single Stack Vent Systems, continued. 917.5. Minimum vertical piping size from fixture. The vertical portion of piping in a fixture drain to a horizontal branch shall be 2 inches. The minimum size of the vertical portion of piping for a water-supplied urinal or standpipe shall be 3 inches. The maximum vertical drop shall be 4 feet. Fixture drains that are not increased in size or have a vertical drop in excess of 4 feet shall be individually vented. 917.6. Additional venting required. Additional venting shall be provided where more than one water closet discharges to a horizontal branch and where the distance from a fixture trap to the stack exceeds the limits in section 917.4. Where additional venting is required, the fixture shall be vented by individual vents, common vents, wet vents, circuit vents, or a combination waste and vent pipe. The dry vent extensions for the additional venting shall connect to a branch vent, vent stack, stack vent, air admittance valve, or shall terminate outdoors. Section 917, Single Stack Vent Systems, continued. 917.7, Stack Offsets. Where fixture drains are not connected below a horizontal offset in a stack, a horizontal offset shall not be required to be vented. Where horizontal branches or fixture drains are connected below a horizontal offset in a stack, the offset shall be vented in accordance with section 907. Fixture connections shall not be made to a stack within 2 feet above or below a horizontal offset. 917.8. Prohibited lower connections. Stacks greater than 2 branch intervals in height shall not receive the discharge of horizontal branches on the lower 2 floors. There shall be no connections to the stack between the lower 2 floors in a distance of not less than 10 pipe diameters downstream from the base of the single stack vented system. 917.9. Sizing building drains and sewers. The building drain and building sewer receiving the discharge of a single stack vent system shall be sized in accordance with Table 710.11. Section 917, Single Stack Vent Systems, continued. 917.7, Stack Offsets. Where fixture drains are not connected below a horizontal offset in a stack, a horizontal offset shall not be required to be vented. Where horizontal branches or fixture drains are connected below a horizontal offset in a stack, the offset shall be vented in accordance with section 907. Fixture connections shall not be made to a stack within 2 feet above or below a horizontal offset. 917.8. Prohibited lower connections. Stacks greater than 2 branch intervals in height shall not receive the discharge of horizontal branches on the lower 2 floors. There shall be no connections to the stack between the lower 2 floors in a distance of not less than 10 pipe diameters downstream from the base of the single stack vented system. 917.9. Sizing building drains and sewers. The building drain and building sewer receiving the discharge of a single stack vent system shall be sized in accordance with Table 710.11. Section 917. Single stack vent systems. Continued. Discussion. Continued. The length of the trap arm is limited to reduce any suction buildup, and the stack is oversized to limit the internal air pressure and vacuum buildup. Stacks greater than 2 branch intervals in height are prohibited from receiving the discharge from horizontal branches on the lower 2 floors. The separate stack serving the lower 2 floors is required to connect to the building drain at a distance of not less than 10 pipe diameters downstream from the base of the connection of the single stack vented system. This proven method has been laboratory tested to determine sizing and installation requirements that provide proper venting to the drainage system. Section 1002.1. Floor drains and multi-level parking structures. 1002.1. Fixture traps. Each plumbing fixture shall be separately trapped by a liquid sealed trap, except as otherwise permitted by this code. The vertical distance from the fixture outlet to the trap weir shall not exceed 24 inches, and the horizontal distance shall not exceed 30 inches measured from the center line of the fixture outlet to the center line of the inlet of the trap. The height of a clothes washer standpipe above a trap seal shall conform to section 802.4. The fixture shall not be double trapped. Exceptions. Section 1 through 3, no changes to text. Section 4. Floor drains and multi-level parking structures that discharge to a building storm sewer shall not be required to be individually trapped. Where floor drains and multi-level parking structures are required to discharge to a combined building sewer system, the floor drains shall not be required to be individually trapped, provided they are connected to a main trap in accordance with section 1103.1. Section 1002.1. Floor drains and multi-level parking structures. Continued. Please review this diagram of floor drains and a multi-level parking structure. Section 1002.1. Floor drains and multi-level parking structures. Continued. Discussion. Floor drain traps located in unheated multi-level parking structures are problematic because the traps can be damaged during freezing conditions. The liquid in traps for floor drains and covered parking levels usually evaporates, as there is little, if any, water runoff on the covered levels. Heat tracing and insulation are also not reliable in these locations. A main trap for the parking structure floor drain system is required in accordance with section 1103.1. The trap requirement will prevent sewer gas from entering the multi-level parking structure. Sections 1002.4 and 1002.4.1. Trap seal protection against evaporation. 1002.4. Trap seals. Each fixture trap shall have a liquid seal of not less than 2 inches and not more than 4 inches, or deeper for special designs relating to accessible fixtures. 1002.4.1 Trap Seal Protection. Trap seals of emergency floor drain traps and traps subject to evaporation shall be protected by one of the methods in section 1002.4.1.1 through 1002.4.1.4. 1002.4.1.1 Potable water supplied trap seal primer valve. A potable water supplied trap seal primer valve shall supply water to the trap. Water supplied trap seal primer valves shall conform to ASSE 1018. The discharge pipe from the trap seal primer valve shall connect to the trap above the trap seal on the inlet side of the trap. Sections 1002.4 and 1002.4.1 Trap seal protection against evaporation. 1002.4.1.2 Reclaimed or gray water supplied trap seal primer valve. A reclaimed or gray water supplied trap seal primer valve shall supply water to the trap. The water supplied trap seal primer valves shall conform to ASSE 1018. The quality of reclaimed or gray water supplied to the trap seal primer valves shall be in accordance with the requirements of the manufacturer of the trap seal primer valve. The discharge pipe from the trap seal primer valve shall connect to the trap above the trap seal on the inlet side of the trap. 1002.4.1.3 Wastewater supplied trap primer device. A wastewater supplied trap primer device shall supply water to the trap. Wastewater supplied trap primer devices shall conform to ASSE 1044. The discharge pipe from the trap seal primer device shall connect to the trap above the trap seal on the inlet side of the trap. 1002.4.1.4 Barrier type trap seal protection device. A barrier type trap seal protection device shall protect the floor drain trap seal from evaporation. Barrier type floor drain trap seal protection devices shall conform to ASSE 1072. The devices shall be installed in accordance with the manufacturer's instructions. Section 1002.4 and 1002.4.1 Trap seal protection against evaporation continued. Discussion. Section 1002.4 has been expanded to cover two additional types of trap seal protection devices and to distinguish between the different types of water supplied trap seal protection devices. Potable water supplied trap seal devices have been an industry standard for decades. However, with greater reliance on alternate sources of non-potable water, such as reclaimed water and gray water, the quality of those types of water has a bearing on the performance of water-supplied trap devices. The manufacturer of those devices must be consulted where alternate sources of water are being supplied to the devices. Section 1003.1 Interceptors and Separators. 1003.1 Where required, interceptors and separators shall be provided to prevent the discharge of oil, grease, sand, and other substances harmful or hazardous to the public sewer, the private sewage disposal system, or the sewage treatment plant or processes. Discussion. The IPC now recognizes that waste must travel through some portion of the building drainage system in order to get to the interceptor. Removing the text building drainage system has addressed the misconception that a device is required to be installed adjacent to each and every fixture that discharges any liquid that may need to be separated prior to entering the public or private systems. Section 1003.3.1 Alternate Grease Interceptor Locations. 1003.3.1 Grease interceptors and automatic grease removal devices required. A grease interceptor or automatic grease removal device shall be required to receive the drainage from fixtures and equipment with grease-laden waste located in food preparation areas, such as in restaurants, hotel kitchens, hospitals, school kitchens, bars, factory cafeteria, and clubs. Fixtures and equipment shall include pot sinks, pre-rinse sinks, soup kettles or similar devices, wok stations, floor drains or sinks into which kettles are drained, automatic hood wash units, and dishwashers without pre-rinse sinks. Grease interceptors and automatic grease removal devices shall receive waste only from fixtures and equipment that allow fats, oils, or grease to be discharged. Where lack of space or other constraints prevent the installation or replacement of a grease interceptor, one or more grease interceptors shall be permitted to be installed on or above the floor and upstream of an existing grease interceptor. Section 1003.3.1 Alternate Grease Interceptor Locations continued. Discussion. Combination of grease interceptors are now allowed to be provided for renovation projects involving existing buildings where there is insufficient space or it is cost prohibitive to install a large enough in-ground interceptor, usually a gravity type, to meet local sewer ordinance requirements. Ordinances have become more restrictive to address the need to prevent public sewer lines from excess amounts of grease and lessen the burden on the sewage treatment facilities. Section 1003.3.4 Hydromechanical Grease Interceptors. 1003.3.4 Hydromechanical Grease Interceptors and Automatic Grease Removal Devices. Hydromechanical grease interceptors and automatic grease removal devices shall be sized in accordance with ASME A112.14.3 Appendix A, ASME A112.14.4, CSA B481.3, or PDI G101. Hydromechanical grease interceptors and automatic grease removal devices shall be designed and tested in accordance with ASME A112.14.3, Appendix A, ASME A112.14.4, CSA B481.1, PDI G101, or PDI G102. Hydromechanical grease interceptors and automatic grease removal devices shall be installed in accordance with the manufacturer's instructions. Where manufacturer's instructions are not provided, hydromechanical grease interceptors and grease removal devices shall be installed in compliance with ASME A112.14.3, ASME A112.14.4, CSA B 481.3, or PDI G101. This section shall not apply to gravity grease interceptors. Section 1003.3.4 Hydromechanical Grease Interceptors. Continued. Discussion. The plumbing industry has standardized on the terms hydromechanical and gravity for the two general types of grease interceptors being used. The requirements in Section 1003.3.4 and its subsections have never been intended to apply to gravity-type grease interceptors. The new terminology makes a clear distinction between the two types in order to provide clarity regarding the applicable requirements for each type of grease interceptor. The PDI G102 standard, testing and certification for grease interceptors with fats, oil, and grease fog, sensing and alarm devices, expands on the already recognized PDI G101 by including the testing and certification of alarm devices that can be provided on interceptors already complying with PDI G101. The alarm device on a hydromechanical grease interceptor monitors the level of grease captured in the unit and provides both a loud audible signal and a visible signal when the accumulated fog in the interceptors need to be removed. Section 1003.3.6 Gravity Grease Interceptors. 1003.3.6 Gravity grease interceptors and gravity grease interceptors with fats, oils, and grease disposal systems. The required capacity of gravity grease interceptors and gravity grease interceptors with fats, oils, and grease disposal systems shall be determined by multiplying the peak drain flow into the interceptor in gallons per minute by a retention time of 30 minutes. Gravity grease interceptors shall be designed and tested in accordance with IAPMO/ANSI Z100. Gravity grease interceptors with fats, oils, and grease disposal systems shall be designed and tested in accordance with ASME 112.14.6, IAPMO/ANSI Z1001. Gravity grease interceptors and gravity grease interceptors with fats, oils, and grease disposal systems shall be installed in accordance with the manufacturer's instructions. Where manufacturer's instructions are not provided, gravity grease interceptors and gravity grease interceptors with fats, oils, and grease disposal systems shall be installed in compliance with ASME A112.14.6 and IAPMO/ANSI Z1001. Section 1003.3.6 Gravity Grease Interceptors. Discussion. Until now, the IPC has not addressed or regulated gravity-type grease interceptors, which are most often installed underground. Gravity grease interceptors work by reducing the wastewater flow velocity so that grease floats and solids settle to the bottom of the tank. Wastewater between these two layers is allowed to pass into the sewer system. Gravity grease interceptors can be fitted with fats, oils, and grease disposal systems so that such material can be reduced into water form, thus extending the required cleaning intervals of the tank. Section 1003.3.7 Direct connection of grease interceptor discharge. 1003.3.7 Direct connection. The discharge piping from a grease interceptor shall be directly connected to the sanitary drainage system. Discussion. In new construction, designing plumbing systems to accommodate grease interceptors rarely presents any problem with direct connection of the discharge to the sanitary drain system. In existing buildings, direct connection is difficult because drain piping is often not located in a convenient location or is buried below concrete slabs. Sometimes, what is thought to be an appropriate solution is to discharge the grease interceptor by indirect connection to a floor sink or other waste receptor. Even though this defies logic, the code did not prohibit this practice. Now, grease interceptors must be directly connected to the sanitary drainage system. Section 1003.4 Oil separator required. 1003.4 Oil separators required. At repair garages where floor or trench drains are provided, car washing facilities, factories where oily and flammable liquid waste are produced, and hydraulic elevator pits, oil separators shall be installed into which oil-bearing, grease-bearing, or flammable waste shall be discharged before emptying into the building drainage system or other point of disposal. Exceptions. 1. An oil separator is not required in hydraulic elevator pits where an approved alarm system is installed. Such alarm systems shall not terminate the operation of pumps utilized to maintain emergency operation of the elevator by firefighters. 2. Oil separators shall not be required in a non-hydraulic elevator pit. Section 1003.6 Clothes washer discharge interceptor. 1003.6 Clothes washer discharge interceptor. Clothes washers shall discharge through an interceptor that is provided with a wire basket or similar device, removable for cleaning, that prevents passage into the drainage system of solids 1/2 inch or larger in size, strings, rags, buttons, or other materials detrimental to the public sewage system. Exceptions. 1. Clothes washers in individual dwelling units shall not be required to discharge through an interceptor. 2. A single clothes washer designed for use in individual dwelling units and installed in a location other than an individual dwelling unit shall not be required to discharge through an interceptor. Section 1003.6 Clothes washer discharge interceptor continued. Discussion. The changes to this section clarify what the code requires for interceptors for clothes washer discharge. The main section now requires interceptors for all applications. The new exceptions provide relief from this requirement for clothes washers in individual dwelling units and for a single individual dwelling unit type washers installed anywhere else. For example, a small restaurant or a hand car wash might have a single residential type clothes washer for washing towels. There is no need to have interceptors for these minor applications. Section 1003.9 Venting of Interceptors and Separators. 1003.9 Venting of Interceptors and Separators. Interceptors and separators shall be designed so as not to become airbound. Interceptors and separators shall be vented in accordance with one of the methods of Chapter 9. Discussion. It is difficult to determine whether the contents of an interceptor or separator could be siphoned out by conditions of the piping downstream of these devices. The best precaution against siphoning is for a vent to be installed on the unit in accordance with the manufacturer's instructions, or where the manufacturer does not provide a vent connection, on the discharge piping of the separator or interceptor. Section 1101.7 Roof Design. 1101.7 Roof Design. Roofs shall be designed for the maximum possible depth of water that will pond thereon as determined by the relative levels of roof deck and overflow weirs, scuppers, edges, or serviceable drains in combination with the deflected structural elements. In determining the maximum possible depth of water, all primary roof drainage means shall be assumed to be blocked. The maximum possible depth of water on the roof shall include the height of the water required above the inlet of the secondary roof drainage means to achieve the required flow rate of secondary drainage means to accommodate the design rainfall rate as required by Section 1108. Section 1101.7 Roof Design Continued. Table 1108.1 Size of secondary scuppers for a 10.2 inch per hour rate of rainfall. Please review this chart of secondary scupper sizing for a 10.2 inch per hour rate of rainfall at your own rate. To adjust this table for other than a 10.2 inch design rainfall rate, multiply the square footage on the table by 10.2, then divide by the desired rainfall rate. This table does not apply to scuppers with a vertical opening height that is less than the head height. Example, for 4 inches of design rainfall rate, a 4-inch long scupper with a 1-inch head would accommodate 286 square feet. That would be 112 times 10.2 divided by 4, equaling 286. Section 1105 Roof Drain Strainers. 1105.1 General. Roof drains shall be installed in accordance with the manufacturer's instructions. The inside opening for the roof drain shall not be obstructed by the roofing membrane material. Discussion. Prescriptive requirements addressing roof drain strainers have been deleted and replaced with a reference to the manufacturer's instructions. The provisions that were deleted predate the development of current roof drain standard, ASME A 112.21.2M. Their original requirements appeared in the ANSI A 40.8-1955 standard and were the basis of the legacy codes. With the reference to ASME A 112.21.2M and Section 1102.6, the sizing and design of the roof drain is now regulated by the standard. The following table provides a comparison of the sizing of the strainers based on Section 1105.1 of the 2009 IPC and ASME A 112.21.2M. It is obvious that the 2009 code language does not require nearly the flow area of the strainer as compared to what the current standard requires. Sections 1105.2 and 1106.2. Sizing of roof drains, vertical and horizontal storm drain piping. 1105.2. Roof drain flow rates. The published roof drain flow rate, based upon the head of water above a roof drain, shall be used to size the storm drainage system in accordance with Section 1106. The flow rate used for sizing the storm drainage piping shall be based on the maximum anticipated ponding at the roof drain. Please review Table 1106.2 Storm Drain Pipe Sizing at your own rate. Sections 1105.2 and 1106.2. Sizing of roof drains, vertical and horizontal storm drain piping. Continued. Discussion. A recent research project by the American Society of Plumbing Engineers, ASPE, Research Foundation revealed that roof drains are the limiting factor in the design of storm drain systems. The previous design philosophy was the diameter of the piping system was the limiting factor. Actual testing of roof drains indicated that the roof drain assembly is the limiting factor. Existing tables 1106.21, 1106.22, and 1106.3 have been deleted and replaced by table 1106.2. which covers the sizing of vertical and horizontal storm drain piping. The design process is to 1. Choose a specific roof drain based upon the manufacturer's published flow rate data. 2. Verify that the head of water required for that flow rate does not violate the structural capacity of the roof. And 3. Choose pipe sizes that can accommodate the design flow rate. The location and elevation of secondary roof drains and scuppers must be closely coordinated with the design of the head of water of the primary roof drain. Sections 1106.3 and 1106.6 Sizing of gutters and leaders. 1106.3 Vertical leader sizing. Vertical leaders shall be sized based on the flow rate from horizontal gutters or the maximum flow rate through roof drains. The flow rate through vertical leaders shall not exceed the values that are specified in Table 1106.3. Discussion. Prior tables were unnecessarily complex and not well understood. The flow in gallons per minute of 1 inch per hour rainfall on 1 square foot of horizontal surface is 0.0 0.104 gallons per minute. Thus, the flow rate in gallons per minute can now be directly and easily compared to the capacities of liters and gutters in the tables. Please review Table 1106.3 Vertical Liter Sizing at your own rate. Sections 1106.3 and 1106.6 Sizing of Gutters in Liters continued. 1106.6 Size of Roof Gutters. Horizontal gutters shall be sized based on the flow rate from the roof surface. The flow rate in horizontal gutters shall not exceed the values that are specified in Table 1106.6. Please review Table 1106.6 Horizontal Gutter Sizing at your own rate. Section 1107 Siphonic Roof Drainage Systems. 1107.1 General. Siphonic roof drainage systems shall be designed in accordance with ASME A112.6.9 and ASPE 45. Discussion. The new technology of siphonic roof drainage systems is being used with much success. It has been found that cost benefits over traditional roof drainage methods can be significant, depending on the material used, project size, and project complexity. The designer is required to submit a final report in writing to the code official upon completion of the installation. A complete operational test of the siphonic roof drainage system is not practical to implement. It is also not a requirement under Section 312 of the IPC for any other drainage system. A complete flow test of a siphonic roof drain system is not required. ASME A112.6.9 and ASPE 45 standards should be consulted for additional information on the design and installation of siphonic roof drainage systems. Section 1108.3 Sizing of Secondary Drains. 1108.3 Sizing of Secondary Drains. Secondary or emergency roof drainage systems, or scuppers, shall be sized in accordance with Section 1108, based on a rainfall rate of 10.2 inches per hour. In sizing secondary roof drain systems using Table 1106.2, 1106.3, and 1106.6, the horizontally projected roof area shall be determined by dividing the horizontally projected roof area for 1 inch rainfall per hour rate by 10.2 inches per hour. Scuppers shall be sized to prevent the depth of ponding water from exceeding that for which the roof was designed as determined by 1101.7. Scuppers shall not have an opening dimension of less than 4 inches. The flow through the primary system shall not be considered when sizing the secondary roof drain system or scuppers. Scuppers shall be sized in accordance with Table 1108.1 or by other national methods using head height of water and flow rate of the scuppers. Chapter 13, Gray Water Recycling Systems. Chapter 13, Gray Water Recycling System. Gray water. Waste discharge from lavatories, bathtubs, showers, clothes washers, and laundry trays. 301.3, Connections to drainage system. Plumbing fixtures, drains, appurtenances, and appliances used to receive or discharge liquid waste or sewage shall be directly connected to the sanitary drainage system of the building or premises in accordance with the requirements of this code. This section shall not be construed to prevent indirect waste systems required by Chapter 8. Exceptions. Bathtubs, showers, lavatories, clothes washers, and laundry trays shall not be required to discharge to the sanitary drainage system where such fixtures discharge to an approved gray water system for flushing of water closets and urinals or for subsurface landscape irrigation. Chapter 13, Gray Water Recycling Systems, continued. Chapter 13, Gray Water Recycling Systems, Section 1301, General. 1301.1, Scope. The provisions of Chapter 13 shall govern the materials, design, construction, and installation of gray water systems for flushing of water closets and urinals, and for subsurface landscape irrigation. See Figure 1301.1 and 1301.1-2. Chapter 13, Gray Water Recycling Systems, continued. Please review Figure 1301.1 and 1301.1-2 at your own rate. Chapter 13, Gray Water Recycling Systems, continued. Discussion. The relocation of provisions from Appendix C to the new Chapter 13 brings the information addressing gray water recycling systems into the body of the code to enable the technology to be more easily implemented. The use of gray water as an alternative water source is becoming highly desirable due to the significant water savings and the shortage of potable water supplies in some areas of the country. This new chapter will promote the reuse of gray water for subsurface irrigation and the flushing of water closets and urinals. Where provisions are located within an appendix chapter of the code, they must be specifically adopted in order to be enforceable. Moving the provisions into the body of the code will promote the green concept of using alternative water source where possible. Section 1301.9.6 Overflow. 1301.9.6 Overflow. The storage tank shall be equipped with an overflow pipe having a diameter not less than that shown in Table 606.5.4. The overflow pipe shall be protected from insects or vermin and shall discharge in a manner consistent with stormwater runoff requirements of the jurisdiction. The overflow pipe shall have a discharge of a sufficient distance from the tank to avoid damaging the tank foundation or the adjacent property. Drainage from overflow pipes shall be directed to prevent freezing on walkways. The overflow drain shall not be equipped with a shutoff valve. A cleanout shall be provided on each overflow pipe in accordance with Section 708. Conclusion. Thank you for selecting Advanced Con Ed to provide the continuing education credits you need to fulfill your licensing requirements. We hope you found this presentation helpful to make you a better tradesman. This presentation is available to you anytime in the event you need to reference it in the future. Again, thank you for reviewing Advanced Con Ed's presentation of the significant changes to the 2015 International Plumbing Code with the State of Oklahoma Uniform Building Code Commission's Amendments and Modifications, Part 2.